This is a lesson on chromatography. Chromatography, chroma is a Greek root word for color. Originally, what they did was separate mixtures into color. So chromatography is used to separate mixtures analyze, separate, figure out what's in a mixture into its parts. So chromatography is separating mixtures into parts. There are many different ways of doing this. There are many different ways. Each type is better for some substances than others. Most chromatography involves a stationary phase. Stationary phase does not move. It serves to slow down components of the mixture, and so it doesn't move, and it slows down or attracts parts of the mixture in different amounts. There's also the mobile phase. The mobile phase moves, and what it does is it transfers or moves or transfers the different parts of the solution down. The way chromatography works is the entire idea is some particles, some types of parts of the mixture, some parts of the mixture stick better, more attracted to, better to the stationary phase, and when that happens, it is held back. It slows down so it does not travel either so far or so fast, one of the two. So this is left behind. Some parts of the mixture, while some parts are more attracted to the mobile phase, if it's more attracted to the mobile phase, they tend to move further or faster. Depends on what type of phase you're doing. Care must be taken to pick the correct type. You need to use the correct type for the mixture that you have. Sometimes the particles are equally sticky or they don't move at all. So you need to worry about the mixture, the mobile phase, and the stationary phase so that you can have a nice separation and you can tell the difference between the parts. The simplest, easiest type of chromatography is paper chromatography. Paper chromatography uses paper as the stationary phase of some sort. And you put a spot or something onto the paper and it is separated by a solvent. So you got to use the correct solvent if you're using. Typical on this is ink dyes or some such things like that. Ink or markers is used a lot for paper chromatography. First of all, you need to have a color because this separates things out, and you can tell the differences by different colors if you have different dyes or something like that. So first off, you need color change. They all can't be the same color or colorless, otherwise it won't work. Second of all, you need to make sure that your solvent or your mobile phase will dissolve the ink or the dye that you have. You don't want to use a water if you have a waterproof pen or something like that. So the choice of the solvent is important. This is also relatively really cheap to do. What they use on this chromatography is something called an RF ratio. It's the ratio of the distances of the distance traveled by a set spot or dye compared to the solvent. So the ratio of the distance of the spot to the solvent, usually expressed as a decimal. And then what you do is you compare these RF values to your known substance. You can tell if it's the same thing or not by the ratio. Sample what you do with this RF is you have a strip of paper and you make a mark across in pencil so that it won't streak. You put a dot of your substance and you dip it into a little bit of the solvent. You don't want the dot below the solvent surface because then it will run out into the solution. And what happens is it'll pull the water up, the water will come up and it'll get wet. And so you have a dot of ink there. If this distance of the solvent traveling is 10, usually measure to the middle of your dot. If that's 8, then the RF is 8 over 10 or 0.8. They're expressed as decimals. It's a ratio. If you have another substance that has the same color and the same ratio, then you can say that those are the same substance. TLC is another type of chromatography, which is thin layer chromatography. What it is a piece of plastic with a special coating on it that is that will fluorescent or show up in with a black light. It'll glow bright white. And what you do is the same idea. Use the same solvent. You mark a dot on the paper and you do that. The only difference is if you will not see anything. And this is useful if you have colorless solutions, no dyes. You won't see anything unless you use a black light. But if you shine that black light on there, magically you'll see the dot. What happens is the substance hides the fluorescent background and it'll cast a shadow. So the whole thing will glow white except for the thing that you're looking at right there. Okay. This is a bit more expensive. Liquid chromatography or column chromatography what you have is you have a tube filled with a packing material and it's either open or closed. So you have a tube filled with some sort of a material. Usually it looks like a syringe, and you got this absorbent material there, and you put the liquid that you're looking at, the mobile phase, it will be the solution that you're looking at, dump it in there. So the sample is put on top, and the mobile phase is added. So you put your sample on top and let, or it's in the mobile phase, either one, and you let it drip in. So you put the sample on top, and then you add the solvent, the mobile phase, or the solution itself, and it comes out. Now you can do this with high pressure. You can use a syringe or some other type of thing, high pressure, or gravity. Gravity is really slow, it's dripping. And you can do two things. You can separate these out by time. You collect a sample for 1 minute or 5 minutes, whatever the interval is. This is by gravity usually. So you separate by time, you collect it, and that's one. Then next minute you put in another one, next minute you put in another one, and you separate them out by time. Or you can separate by solvent. You can use water as the first solvent, and you collect that, and then you can use a weak, like a 1 or 2% solution of the solvent, and then a 5% solvent, and so on, up to maybe 70%. So you collect things that are more soluble in solvent as you go along. It's another way of doing it. So that's liquid chromatography. The last type is gas chromatography. And this is related to time. Same idea, same concept as liquid chromatography, except what you do is you put a sample and you heat it up electrically or flame, and it's in a gigantic long tube that's coiled up many feet. Then what you do is you flush it with an inert gas, nitrogen or argon or something like that, and you have a sensor at the end, and that sensor detects if there's something other than that inert gas coming through. If it comes through, what it does is it makes a little leap on a thing. So you can have different substances. Those would be a pure substance. If you have a mixture, you have a series of peaks, and you can analyze that by quantity, how big the peak is, and the identity of the substance itself, where the peak is. And then this is hooked up to a huge computer bank listing all sorts of different compounds. It's like where you do a CSI, where they say this is a sample of turpentine produced in North Carolina in 1978. Now all that stuff, what they do is they have this huge data bank and they sample it. For example, if you have the suspect is this, that's at the crime scene, and you have 3 unknowns. You have this one, unknown A, unknown B, unknown C. Well, A is a different substance entirely. C is way too much. So suspect B would probably be the one, because it's matching up pretty closely to what the crime scene is. So you investigate that. Gas chromatography is very expensive. and it's expensive to run, so you don't use those for any old time. You would need a very good reason for doing this. So you would probably do one of the other ones first, and then come back and see if you can't define more details, something, if you have gas chromatography. That's the end of chromatography.